It's the ERP Confab. I'm David Essex, industry editor at Informa Tech Target's ERP website. Dassault Systèmes could be taking product design into new dimensions by integrating its 3D experience platform with the Apple Vision Pro mixed reality headset. The combination will enable product designers and buyers to interact with what the company calls a virtual twin, a more immersive, information-rich type of digital twin. The headset's cameras and sensors allow the virtual twins to interact with the physical world with scientific accuracy, according to the company. For example, a user could see if a piece of equipment fits inside their factory and the impact of heating and cooling systems on the machine. It's a new application of spatial computing, and it could have important uses in product design, collaboration, testing, manufacturing, and marketing. In the podcast, Tom Acklin, CEO of Dassault Systèmes 3D Excite, explains how the company worked with Apple to integrate the platforms, some of the new capabilities that spatial computing provides, and how the technology might evolve in the future. Tom, in February, your parent company, Dassault Systèmes, announced that its 3D experience platform will be integrated with the Apple Vision Pro 3D headset. Can you give the listeners the highlights of that announcement, including maybe the role of the 3D Live Vision OS app?
Certainly. So what we announced back in February was really a new capability on the 3D Experience platform. And that capability is fundamentally the possibility to enable spatial exploration of parts and assemblies, which are published by Dassault Systèmes authoring apps into the 3D Experience platform so that it could be accessed very simply, all that information. And part of that was also an integrated tool chain for authoring immersive and interactive experiences, which actually bring more complex multi-actor and multidisciplinary scenarios to life. So all of this is made possible on the toolchain, which is resident on the 3D Experience platform, but it's accessed via a new Apple Vision Pro app, which we anticipate being distributed by the enterprise app stores of our clients so that they can get access, so the end users of our clients can get access to all of those scenarios through the 3D Experience platform.
You are the CEO of 3D Excite. Is that like a company owned by Dassault Systèmes, or what is that?
It's a great question. So Dassault Systèmes has a number of different brands that focus on different parts of the value chain associated with our clients' businesses. And my part, so 3D Excite, is really dedicated to focusing on the commercialization of manufactured product. So you have other brands like Katia or SolidWorks or Simulia, which are all tied up with the modeling and simulation, for example, of manufactured product and other types of goods. Delmia, which is focused on, for example, production systems, which allow people to manufacture all of those designs. And 3D Excite is basically the segue to get from engineering data to experience, which is connected to those products, obviously, both from development, but also in terms of how those products are used in people's everyday lives.
So your company partnered with Apple, and according to the press release back in February, it was a quote deep engineering level collaboration. Can you drill down into what that means? What kind of engineering level work needed to be done?
So let me just acknowledge, first of all, it's a great question that I guess words used in a press release are very carefully chosen. So I'm going to have to be equally careful in how I answer that.
Okay.
So I'd start off really by acknowledging the work of the Apple developer relations team who work with developers such as ourselves in terms of leveraging technology that Apple produces within specific use cases or application domains. So, actually, when you go about starting to create a new possibility which leverages Apple's technologies, it's those teams who really help developers such as ours get to grips with what Apple's technology can do in the context of their specific use case. But I think it's probably worth talking a little bit more broadly about what's going on in the context of spatial computing and how the world, if you will, that Apple is looking at in the context of spatial kind of overlaps or comes together with the world of Dassault Systèmes and what Dassault Systèmes does as a company. Probably the easiest way to look at that is to look at the underlying technology trends. And there are really three that I'd just like to go through, which kind of bring us together around this idea of spatial computing. I mean, the first one is really related to this idea of software-defined products. So, I've actually lost count with the number of times that our automotive clients talk about the software-defined vehicle as being like the iPhone on wheels, right? It's kind of a trope, which is a little bit hackneyed these days, but at the same time, there is some truth to it because you're talking about the architecting a new class of product whose behavior and the value that it delivers to the people that use it is able to change over time. It's not just released once, it's released every single time you introduce new features and functions to that vehicle, in that case, throughout its lifetime in the field. And on the other side of that software defined product equation is that it doesn't just change how you build and architect those products, it affects how we interact with them when we use them. So we often interact with physical products which are enabled with software through media. We encounter functions and features through our phones, through our dashboards, our digital dashboards, and so on, which are really part of the experience of using the product. So that idea of changing products from being these sort of fixed goods that just go through a supply chain and come out the other side into things which are constantly evolving and whose interaction model is constantly evolving throughout their lives is something that really I think is at the heart of why spatial computing is relevant. You could even think of the Apple Vision Pro as a software defined product, for example. But in this case, we're using the Apple Vision Pro and the Vision OS capabilities of Apple technologies together with the 3D Experience platform to help other people define software defined products. Right. That's something that's going on there that I think unifies, our vision for how the world is evolving as much as Apple's. The second thing is really about how 3D is becoming, you could talk about it as being a first class citizen of the internet. So we're seeing 3D become as ubiquitous in terms of how we experience media and how we interact with information that's published in the same way that we used to talk about video. We talked about images and text before that. And to make that happen, you really need to have a lot of deep tech because we're talking about interoperability between the way people experience media and the tools that are used to publish that. So we need standards, and those standards are developed by companies like Dassault Systèmes and others who are playing in the field. And so when we talk about an engineering collaboration, what we're talking about is a contribution to establishing that paradigm of being able to use and work with 3D as if it's just another form of media that we encounter in our everyday lives. I think the third aspect is really the aspect of AI, right? I mean, clearly you wouldn't be able to deliver the kinds of experience that the Apple Vision Pro enables without a lot of AI, without a lot of AI powered compute. And I think there are two elements there which are significant. Obviously, there's just the compute power, the sensors, the silicon, which are on board a device like that. But there's also a reliance on very reliable and trustworthy data with respect to the real world because that idea of spatial computing is really an interaction between content, which is representative of what we see around us, and as I say, all of that compute and silicon, which is sort of using that information to create those immersive and very deep experiences which augment what we see in the physical world with virtual information. So you can see there's these big sort of deep tech paradigms which are going on almost continuously, and then there's product which comes on top of that. And the product in this case is on the one hand, you've got the Apple Vision Pro, on the other hand, you've got our applications which enable users to be able to use the Apple Vision Pro in the context of engineering and definition of new software-defined products.
Can you talk about some of the pieces? So, there's the new, it sounds like an app or
Mm,
application, and
yeah,
then there's obviously the Apple Vision Pro.
yeah.
What other pieces from Dassault Systèmes or from 3D Excite tend
Mm.
to be behind all that or a part of this?
Oh, it's a great question. So, when we talk about these experiences, or we're calling them scenarios in the context of what we're bringing to market in the summer of this year, those scenarios are essentially a way to immerse yourself in sort of complicated multi-actor interactions between things and people's use cases, so what they're trying to achieve with those things. And those scenarios are really created and optimized for use in the context of spatial computing based on engineering data. So behind every one of those scenarios, you've got the real kinematics, you've got the real geometry. I say real in terms of it being a very, very mathematically accurate and precise representation of the things that you're seeing in a spatial scenario. It's that data which is being used to construct those representations. So you've really got behind those scenarios, you've got things like models that have been created in CATIA. You've got multidiscipline simulations, looking at thermodynamics, looking at power flow, which is how objects interact, for example, with a stream of air, for example, or how electromagnetic signals are interact with the physical space. All of that simulation, all of that modeling is essentially used by the tools which are allowing people to construct those scenarios, so that what you see is really, really close to what is actually going to be in the real world, or in fact already exists in the real world, because part of the promise of spatial computing is that it's able to reveal information about real things as well. We're not announcing the capabilities to do that in the summer of this year, but that's clearly the trajectory. And how you intertwine the modeling and simulation of things in the real world with our virtual experiences is sort of the bigger picture. But behind that, you really need a source of truth, which allows us to understand what those things actually do. And that goes into discussions around a production system, for example, which is really a collection of those smart things, right? So how processes are constructed on a line, for example, those are very canonical, they're very detailed, prescriptive processes which are authored to allow people, for example, on a line to be able to operate a manufacturing line, or indeed recover the operations in a manufacturing line when there's an incident. And so as you craft all of the experiences which you are able to deploy through Apple Vision Pro, you're drawing on all of that equity and all of that science associated with the things and the processes which are governed on the 3D experience platform.
I remember when the Apple Vision Pro was first released, it didn't always get the best reviews. And,
Mm,
and two of the criticisms I remember was that it was too expensive and too heavy. So I have to ask,
mm,
was your company and were you aware of those criticisms? And did you
mm.
think any of those criticisms were valid?
Okay, so that's a great point. Let me come on to that in just a second. I do want to touch on what makes this a little bit different
Okay.
to some of the other things that we've done, in the context of XR, in the context of VR, AR over the years. So one of the things that tool chain that I was just talking about in terms of the ability to leverage information about the way things are constructed or about their nature and expose that in the context of these immersive experiences is that this is all baked into the tool chain on 3D experience. So in other words, the processes to create these immersive applications or scenarios used to be quite discontinuous, right? They would be sort of a handoff that took place between, computer-aided design, computer-aided engineering, and then the creation of those scenarios. And one of the things that's really different about our approach here is that we're putting the power to create those scenarios into the hands of the people who are actually doing the modeling, the simulation, the process design. So we're enabling people at source, as it were, to be able to create the scenarios directly from the source material. And that is a real speed win, because what we found in the past is that it took a long time to go from that raw material into those scenarios, and therefore by the time you'd finished, you'd realize, you'd have to go back and redo them all again because they just changed. So that's just one aspect. But coming to the question about, some of the commentary around the Apple Vision Pro specifically, as I mentioned, we've been working in the XR space for over a decade in a variety of different use cases, in the design space, in engineering, and in manufacturing, and in commercialization, actually. So we've seen a lot of different. We've seen the evolution of the space over the last decade come to pass. And I think, even before the Apple Vision Pro arrived, there was a lot of rumors. There's a lot of commentary. You mentioning
Mhm.
commentary going on even before it got there. So we were really excited about the arrival of this technology, not only because of what it is, and frankly, we were not at all disappointed with the capabilities of the device in the
Mhm.
context of the use cases that we are focusing on, but also because the nature of having Apple as a player in this space is fundamentally different, not
Mhm.
only because they're big and because they're significant as a company, but also because of their ecosystem, because of the intertwined nature, as I was talking about before, with software-defined vehicles, software-defined products, the way we consume products versus the way we design them. You can see that there's a segue between the stack that's allowing people to design things or experience things in a design engineering context, and the way that ultimately they will experience and interact with them, perhaps not using an Apple Vision Pro, but using an iPhone, for example, or an iPad. So it's really significant that this technology is based on that broad ecosystem, and the technologies which are used to govern things like the Apple Vision Pro are the same ones that are used to govern other Apple-based devices in an enterprise context. So it's a lot easier to deploy. So, while we certainly did see those comments, and I think, perhaps for other use cases, which I think the device ultimately will be used for, or evolutions of the technology going forward will be used for, some of those, might be fair enough. They're not particularly significant in the way that we are planning to use it, but I can see why some people would say, this might be something that is a problem over a longer period. That said, I think it's been clear from what Apple has said that this idea of spatial computing as a phenomenon and the software and hardware technologies necessary for enabling it is a long-term commitment. And I think they were pretty clear from day one, actually, that the first iteration, has a certain role to play in terms of establishing that paradigm. But the diffusion of that paradigm into people's everyday lives is clearly several iterations down the road. And I think that's clearly where we see this going. We see this really as a broader movement, a broader trend, a broader evolution of how we work. And so I think we sort of need to look at that in the context really of where we are in terms of adoption, in terms of maturation of these technologies. I think also when you look at how some of the other experiences, so things which are perhaps more oriented towards entertainment, and I don't know if you've had the chance to see some of the spatial video, for example, which has been developed for the Apple Vision Pro. I mean, it's amazing. It's
Yeah.
absolutely mind blowing. And so, just when you see one of those experiences, which is perhaps more of a consumer oriented experience, you can
Right.
see why this device needs to exist, right? I mean, it's clear. And even since then, I think just 3 weeks ago, they started recording, or a partner started recording things. I think it was Metallica concerts and so on. And that was only a few weeks ago. So
One of my favorite bands.
I think we can see that this is not a one and done, right?
Yeah.
And so while there may have been some criticism there, I think we're fairly sanguine about it. Not only because it doesn't really affect the use case we're looking at now, but because this isn't the last iteration of this type of product, I don't think.
We've talked about how it works, more or less,
Yeah.
but what does this new hardware software combination and the 3D Live Vision OS, what does it
Mm,
actually enable people to do?
mm. So that's an interesting question. So when we looked into this, what we found out was that the biggest value today is really often on the interface between two people,
Hmm.
so or groups of people. And it's really about one team of experts who's working on a particular facet of what we would call a virtual twin, being able to explain and expose their creativity and their designs, their engineering to another group who really need to understand that fundamentally to do their job. And of course, there have been ways of exposing people's work through 2D screens, even 3D experiences on flattened on a 2D screen in the past, or using other kind of devices. There have been precursors to this. But in terms of the use cases, we feel that that is where the value is today. And that's what we focused on in terms of enablement to allow people to do new things. So I'll give you a couple of examples. And these were examples that we showed actually around the time of the launch. One of the things is really to allow people who are designing a very, very specialized solution to the buyer or the user of that solution in the context of its use. So, for example, if I'm somebody who is determining which types of robotics are going to be deployed into a manufacturing facility, just as an example, it could be a lab, it could be many places where we see these cobots and these robots starting to come through. I can kind of define my RFP, I can list out all the things it's got to do, I can explain what the constraints are in operational environment, et cetera, et cetera. And I can come back with a systems model and mechanical simulations and diagrams and all the rest. But can I actually put that device as it's being construed by the supplier into the hands of the person that's going to use it before I actually deliver it so they can grab hold of it, play with it, and see, oh, yeah,
Hmm.
it does exactly what I need to do. And that's a very, very different way of showing somebody that what you're going to do for them is going to meet the task at hand. So that's just one example where you're talking about, line building or even product design if it's a very bespoke product, to be able to actually explain to somebody why your design or your solution is going to actually meet the needs that they've expressed to you. There are others. You can look at, for example, I mentioned production systems.
Mhm.
So these things are very, very complex. Lots of different work steps. Lots of interplay between people, software, hardware, operational programming of lines. For example, one of the things that we showed was how can I make sure at a very early stage that I can design the right kind of affordances to meet exceptional conditions on a line. So we actually showed a typical situation which happens quite often in welding, for example, where the welding head gets stuck to the thing you're welding, right? I mean, you'd have thought we'd have solved this by now, but it happens. So if you just take that example, we know that there's a risk that this is going to happen. Now, the maintenance engineer who's going to define those processes for, okay, what do we do when these exceptional conditions arrive? It's very useful for them to sort of get into the line as it's being
Mhm.
designed and say, okay, right, we're going to need a step ladder over there, we're going to need a hacksaw over there, whatever it is that we're going to need to do to kind of recover from the situation, and actually make sure that those playbooks are already well catered for as we plan the commissioning of the line. Again, that's sort of an interaction between the line process engineer who's defining what those processes are, and in fact the maintenance engineer who's really critiquing that to say, okay, we haven't just got the happy path here. We've got all these exceptional cases covered as well. And the third one, which we showed, and I think this is another big topic, is around training.
Mhm.
And this bleeds into education a little bit. But even if we just stay with manufacturing operations for a moment, everyone who's going to be using this future line is going to need to know how to run it, but also how to support it. As standard operating procedures need to be followed. So again, if we can get those people in early and we can take them through those scenarios in a very, very lifelike fashion, it's going to speed up the way that we can deploy the line. It's also going to speed up, or it's going to maintain the ideal running conditions so that we avoid downtime, and we are able to execute operating procedures efficiently in the everyday life of the line.
Could we just drill down a minute in that second example about the welding and
Yeah.
the person who's, I guess it sounded like trying to intervene and help fix the
Mm.
problem. Are they like going into a virtual world or into the virtual twin
Yes.
and interacting with it? That's how they're doing it?
Yeah, so when you think about a virtual twin, you can look at that from the nano scale, like literally what's happening in that weld head right now, right? All the way up to the system of systems sort of world scale, right? Which is, enormously broad and wide. What we're looking for in the context of what we're launching in June is really the right level of granularity to get things done, right?
Mhm.
So there is an element of focus that is part and parcel of that narrowing, where you're saying, okay, what is it that's actually relevant to the person or the people who are involved in this interaction in the context of the example, the process engineer designing how the robots are moving around, what's going on the line, and the person who's thinking about, okay, what are all the things that could go wrong and how can we make sure that all the facilities are there to recover from that. So there's a narrowing that happens at that point. But once you've got that scenario and you say, okay, this is the thing I want to talk about, and those could be many, many, many of those scenarios being produced, right? Now I'm actually going to immerse myself in the situation that is being put together to allow that transfer of knowledge and know-how to take place. So yes, you're going into the world, but it's the world at the right scale. It's
Yeah.
ideally a one-to-one scale in terms of the geometry, right? It's literally the size of what you're going to encounter, and the things that are moving around you and the noises and stuff that's happening are very, very close to what you're actually going to experience. But we're not talking here about, one of these sort of massive scale factories, which, yeah, might be good to get an overview, but they're not necessarily what is actually needed in the context of that interaction.
Maybe this is a good place to explain the virtual twin versus digital twin concept. I know your
Mm,
company uses virtual twin very consciously and deliberately in
yes.
this context. And I think I know what it is, I think, but can you sort of define it and maybe explain why it's important, why the virtual twin concept is important in this context?
Sure. So I think it's interesting that we have these semantics that sort of make a difference between virtual and digital twin, but often they're used interchangeably, right? I think we should probably recognize that.
Right.
But let's be pedants about it and let's try and
Okay.
maybe explore the nuance there. So I would say, having also worked, in IoT companies, having founded one myself, co-founded one myself, when you talk about the digital twin, what you're often referring to first and foremost is a series of real-time data points or real-world data points which are associated with an instantiated object. So in the context of the example that I was just talking about with robotics, these are the data associated with this particular robot doing this particular task right now in a real factory somewhere in the world. And the aggregation of that information is often what people are referring to when they talk about a digital twin. It's a representation in data of something which is happening in the real world right now. The virtual twin is actually the context of that. So you need a projection space to sort of cast that data onto to get a sense of what it actually means. Otherwise, it's
Right.
just numbers, right? It's just numbers which if you're really trained, you might be able to understand that. But all you're doing then is just creating the virtual twin in your head, right? Yeah, the virtual twin is the contextual parenthesis which gives those data meaning. Every data point that's coming from a sensor is there because someone designed that sensor into its situation, right? They put the sensor into that robot arm, which is recording the stress of the load, which is pulling on the end of the robot arm, for example. So to understand what that load point means, you need the virtual twin so that you can say, okay, so we've just got an overload situation on that particular arm, and that's what's probably happening right now in the context of the real world. So the virtual twin can be very useful to provide non-experts with an understanding of what those data mean. And it can also be very useful if you want to project into the future and talk about something which doesn't even exist yet, right? Because at that point, you're essentially mocking up future scenarios that will ultimately become instrumented and become expressed through typical digital twin mechanisms. So the virtual twin and the digital twin combine essentially to create knowledge and know-how. And they're not discrete, they're interlinked. But I think if we want to be pedantic, you can think of digital twin really as being the physically instantiated thing, and the virtual twin as being that context which gives that data a representation.
So, have any Dassault System customers been able to use prototypes already or maybe beta releases? And if so, can you share a couple of your favorite use cases?
Is a trick question. So we're not actually out in the wild with the product. It's going live in the summer of this year, and there will be a rolling set of announcements that will come throughout the rest of the year as those things become visible publicly. What I would say is that we have a very, very broad set of customers who are working with these technologies in aerospace and defense, in industrial equipment, in transportation mobility, in consumer packaged goods and retail, surprisingly enough, in life sciences. I think some of these examples, perhaps in earlier iterations before we really started to release product, which have been made public, there was some work that was done in the education space around Purdue University, for example, in the US, where Purdue is really involved in the ecosystem of silicon manufacturers. So there's a lot of work obviously going on around the world to expand the capacity that we have to create high grade silicon. A lot of that requires a new generation of engineers to be educated to be able to participate in that expansion. And education is a big space where we see this technology actually being useful because for example, it allows people to get access to a clean room, which is normally very, very constrained in terms of the number of people that can go in and do certain operations in that environment. So you can make things which are available in only very constrained real world conditions to people to try out in the virtual world first so that they can be that much more prepared when they come to do it for real. And there are applications of that outside clean room. You can imagine all kinds of training scenarios which are associated with that. So that's public, and as I mentioned, some of the others you can probably extrapolate from some of the examples that we have published as part of the demonstration, as part of the launch back in February.
Right. So, the broader concept or product category here seems to be spatial computing.
Yes.
How would you explain what that is and why is it important in terms of what is new and different about it?
Okay, so let's start with spatial computing because there's an elevation which we talk about called sense computing that I'll get into at the end of this. But let's start with spatial. The spatial computing paradigm is really kind of a new iteration in the ways that we interact with compute. You could draw a parallel with the command line interpreter giving way to the GUI, right, and then the GUI, the graphical user interface, ultimately giving way to the sort of multi-touch type experiences we interact with every day with phones that not too long ago was completely unknown. It's really come into a phase of adoption and everyday use that 10 years ago would have been unfathomable. And I think if we start to look now at where spatial computing is going, it's really sort of dissolving that interface between the virtual or the digital and the physical world, or the virtual and the physical world, even more completely, so that things around us can become interfaces to virtual information, for example, and physical things can be better represented in a virtual environment because they are that much more close to how we will experience them in the real world when we encounter them. So it's really a new user interface paradigm, is what spatial computing is about. Now, one of the interesting parts of that paradigm is also that these devices, the user agents, used to be, we talked about user agents as browsers, and then we had apps on our app stores. These are user agents. One of the interesting that these user agents allow us to do is actually look into the real world. So you can then start to say, well, if I want to access information that is essentially hidden to us because we've only got our eyes to work with, then spatial computing will give me or us access to things which are behind the physical representations of knowledge and data which we encounter every day. And I think that's really sort of the next event horizon. We're seeing obviously many technology companies invest in those sorts of user agents, which we'll carry around with us. We'll wear them. They'll be part of our interface with the everyday world. And the spatial computing is a requirement to allow us to do that kind of augmentation. Now, if we go beyond spatial computing, what's sort of the next? We sort of talk about this in terms of the idea of being sense computing, because clearly spatial computing is really a way to look at things differently. It's also often using audio as well, also augmented with AI, so that we can interact with things with voice and with our eyes. And we can use gestures, so it recognizes our hands and things like that. But what's the sort of logical conclusion of that? Well, probably it's actually that we start to have an increasing ability to interact with these things, these ideas, using other senses as well, like tactile type experiences. And maybe one day we'll even have, taste and smell and things like that. Now, that's not possible today, but I think the sort of logical progression of spatial computing as an idea is that it becomes that much more immediate for us as human beings to understand what things mean and what things are.
When I hear the term spatial, I think, okay, this is also the in space, located in space,
Mm,
3D. I don't know
yeah,
if we still use the term 4D. Wasn't
yeah.
always sure what that meant, but anyway, so is that a big aspect of that, or am I misunderstanding what the spatial piece is?
No, I think it's accurate. I think you're accurate to say that. And when we talk about the experience of spatial computing, for example, particularly when we think about it in the context of Apple Vision Pro, one of the things that you'll notice is that things which appear in the scenarios and the experiences which are deployed to that device, they are locked in space. So there's none of the kind of flickering around and sort of slightly janky experience maybe of
Oh,
using
really?
previous
Huh.
iterations. They are very, very, very stable. So that really gives that sense of spatial accuracy you're referring to then. By the way, just on the 4D, well, let's introduce the time domain. So that's the element that I was referring to there in terms of being able to look back in time and see how maybe data has can inform representations of how things were a little bit
I
before,
see.
or look forward in time and see things that do not yet exist, but in a very lifelike fashion. So I think if we were introducing the fourth dimension, that's kind of where we'd go with that.
Okay, this is getting a little trippy, so maybe I'm feeling this is a little bit of a college dorm discussion at this point, but I asked for it, I guess. Anyway, so what is your vision? And I guess I said no pun intended earlier, but it is
Mm,
kind of a pun. What's your vision for the future if what we've been talking about, if it becomes more widely adopted?
mm. Well, I think overall, the vision which is driving a lot of this work is about that idea that the way that we interact with things is intermediated by media, and those media are essentially are part of the product behind. So the question is, how do we design those interactions? How do we imagine all of the richness of those experience, we would call them experience universes around things before they exist, and even while they exist, but have not been enriched with the next ideas that we might have to make those things better. So, as a company focused on innovation, Dassault Systèmes is really energized by that idea that we can improve the value that things give people by augmenting them with experience. And there's an element to this which is, I'm sorry for this, is going to go dorm room again. I'm sorry, but I'm going to give it to you
It's
anyway.
okay.
one, of
I actually like it.
one of the things that's kind of imperative about this is that if we think about the last uh, iteration of industrialization, it's been all about horizontal scale, right? Just building more things, more consumption, more media, right? And there's been some pretty obvious uh, externalities associated with that growth that we've come to be concerned about, right? So you can kind of have a discussion there about how do we reduce all of the ingredients that we are putting into things. Pretty soon that becomes a conversation about, is capitalism even working? Dorm room conversation. Um, the other way of looking at it is how we can increase the amount of human value that is derived from all of those atoms. Because if we can make things that are more useful to people, they become more valuable. We're prepared to pay more for them without
Hmm.
wrecking the planet.
Yeah.
So that is an element of vision that I think is really key to this is how can we do more for human beings with less resources? And that's as much about augmenting the value as it is reducing the cost or reducing the impact from a material perspective.
Right. You're preaching to the choir here. I've often had that thought. There's a criticism, it comes up in sustainability and environmental
Mm.
context that our paradigm has been too much more, 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 like you say.
Yeah,
The only way to grow and to have adequate gross national product growth is if you make more things.
yeah,
And we know that, like you say, the negative externalities of that. And I've often wondered, well, wait a minute, there's other ways of creating value
yes,
that,
exactly.
like you say, people are willing to pay for that don't
Yeah.
involve using more
Yes, exactly.
resources.
And
Yeah.
we really believe that that function of things being relevant to people is a function of engineering, because at its core,
Mhm.
engineering is about solving problems for people, right?
Right.
So when we go into this concept of spatial computing, to bring it back down to the conversation today, that's really what we're trying to do. We're trying to make problems go away or make opportunities exist for people by using science, but by then bringing it to life for end
Mhm.
users in the context of use.
So, what are going to be the biggest hurdles, or what are the biggest hurdles right now? And maybe we could
Mm,
talk about technological ones, but sometimes there are even
Societal.
societal and organizational ones. What are
Great
the
question.
hurdles?
Great
Yeah.
question. So, I touched on some of the things that we've been contributing to over the years in terms of standardization. And I think if you are talking about these complex environments of software interacting with things, you obviously need a new kind of standardization to exist that isn't just parts, right, and supply chains, but the interoperability between services, experiences, and things. So that's a big challenge, and there are working groups and going on right across industry to try to formalize some of those specifications to make that sort of scale possible. Just to give you a couple of examples, in the automotive industry, for example, there's a group called the Connected Vehicle Systems Alliance. That's a big group of engineers from OEMs, from suppliers, from technology companies who are trying to sort of define how software and experiences interact with cars, right? So that's one area. The other areas, in terms of the architecture of being able to build that kind of good or that kind of experience, we need new tooling to be able to do it. And there's a whole lot of standards bodies, people like the Object Management Group, which are a group working on the systems engineering standards, which allow engineers to architect that sort of product or that sort of system. So investment in standards and acceptance of standards is key to be able to get any kind of scale. I think the other one, going to go dorm room again. The other one here is trust, right?
Hmm.
Because um, you know when we're talking about the convergence of media with things, that sounds exciting on the one hand, but it's also scary on the other, right? Because the potential for some, again, different kinds of negative externalities are not hard to identify if we look what's happening in certain corners of the media sphere. And how could it all go terribly wrong if we don't have a degree of trust associated with those interfaces and the way that those media representations are, arriving with the people who are looking at them. We really need to solve that. We need to be able to differentiate between, okay, yes, this thing that I'm seeing, which could be incredibly impactful if it's in one of those immersive environments, particularly, this is okay, and this thing that I'm looking at may or may not be okay. I just don't know. So I would say that's sort of an elevation. We've solved the problem, for example, in e-commerce, right? When you go to a website because the infrastructure is there, that's to be trusted. And there's other connection. Even your browser these days will say, "Don't go here." But we need that kind of trust architecture at the level of the sort of interfacing that we have with these complex systems. I think in the longer term, because otherwise we're not going to be able to get the value of greater features and functions and benefits without actually unleashing a world of doubt and fear and problems.
I see. So I think if I understand what you're saying, like you use the e-commerce analogy with these 3D worlds and spatial computing and everything,
Yeah,
we know that bad actors tend to find a way to come up
yeah,
with bad uses of technology. So people might become begun to be afraid, like
yeah,
thinking that whoever's really on the other side
yeah.
is trying to harm me or can't be trusted or that kind of
Right.
thing.
Yeah, exactly. I mean, you could, I mean, I don't want to get into sort of conspiracy theories here, but clearly, if you are in a world where you're in an open, an open system where additional functionality, additional capabilities are constantly being added to these things around us, and we're perceiving those functionalities through these spatial techniques and using them, um, some of those things could start to have real world consequences really fast because there is the interface between real stuff now, and it's not just media. And
Mhm.
so there needs to be some trust architecture at that interface. And we think that that's part of our job, frankly, because much of the architecture of these things is developed using our platforms. The vast majority of connected and electric cars, which are being developed today, are being developed on our platform. So how we secure that interface and make sure that its use is secured is something which keeps us up at night.
Well, Tom, I really appreciate this discussion. It's been one of the more fun and fascinating technology discussions I've had in a while.
I'm pleased to hear that, David. It's been great
Yeah.
talking to you. Thank you for your
Yeah.
question.